we're going to be working with this function that we've worked with in the past, but now we're going to be analyzing its transformations, just like we did with linear. First of all, the parent function is the absolute value of x. If you have just x, you're linear. If you have absolute value bars, you belong in the absolute value family. Secondly, to go to vertex form, it should be the letters a, x minus c plus d. Notice the only difference is they used h and k. Those are old, and we don't use those anymore. So we're going to be looking at the transformations that happen. I think before we get started right here, if you notice all these are plus and minus at the very back, and the letter that's at the very back is D, so we can put a D there. All these numbers are at the very front. At the very front is A, so we'll put an A here. These are also at the front, so we're talking about A. And these numbers are inside the absolute value, and notice inside is C. So first of all, those are the letters that we're discussing. Now we're going to be looking at them. So we're going to put the absolute value parent function. How do I get absolute value in here? You must be on the y equals screen, and then you hit math, and you right arrow over, and there's absolute value. You're going to put x in there, and we're just going to look at the graph of the parent function. It makes a v. And now we're going to go back in here, and we need to put in the second one. So we're going to put in math, absolute value x. Make sure you right arrow to get out and say plus 1. When you hit graph, this function has clearly moved, and it has moved up 1. So I've moved up 1. Now I'm going to go in here and I'm going to take plus 1 and change it to minus 4. So I'm just going to right arrow over and hit minus 4. And when I graph this one, I see that it has moved down 4. So I'm going to say that. The next one I'm going to go in and make it plus 3. And again, go ahead and hit graph. Let's just make sure we think it's going to go up 3, I bet. And it does. So I'm going to say up 3. So you can probably guess this one's going to head down 5. Just to show you quickly, minus 5. There's the parent every time. And there's my new function. It has moved down 5. So to summarize what we've been doing, again, this is our D, which is found at the back. It's back there. And this is our vertical shift. And we did this on linears. We're going to write D here. D from linear is like our B, which is our y-intercept. It's changing where we are on the y-axis. Alright, so before I go and do the second column, we're going to go ahead and move over and do the very last column. So I'm going to keep the parent function in. Down here inside with x, I'm going to type minus 5, and I'm going to get rid of what was outside. So I don't have to retype every time. So when I hit graph, there's my parent. And my new function has moved, but this time it didn't go up or down. It moved to the right 5. That's weird. So I'm going to hit plus 2 because I'm going to put this one in now. And I'm going to go ahead and hit graph. So there's the parent. Now, oh, that one moved to the left 2. So I'm going to change to minus 3. Let's see if it moves to the right, which is what you're, I bet, thinking is going to happen. And sure enough, it moves to the right 3. And then we're going to do plus 1. And we're going to go ahead and hit graph. So there's my plus 1. So it moved to the left 1. So we need to write this down right now. It's going to the opposite direction. it should. That's very important. And don't forget at the top, we said this is C. And it's moving it left and right, which means we have a horizontal movement. And when I see a minus, I'm going to the right. When I see a plus, going to the left. Notice that C is in here with X, and the X-axis goes horizontally. So it makes sense this number is a horizontal shift. Alright, so now we're going to deal with this column right here. So we're going to keep our parent function in, y equals x. I'm going to come here and I'm going to delete, and I'm going to insert a 2. Or you can just type 2 and then go get your absolute value. So, wow, it didn't move up, it didn't move down, it didn't move left or right. It got what we like to say skinnier, thinner. So here's how we decide that. We take the y-axis, and in order to take the blue piece and make it skinnier, you would have to stretch or pull the y-axis from bottom to top. So this is a vertical stretch by 2. A vertical stretch by 2. That does not look like an E. That's a vertical stretch. So I grabbed the top of the y-axis and the bottom and I pulled it. When I pull from both ends, the V gets thinner. It moves in. So if I want to look at 5x, I'm going to put a 5 there and hit graph. Again, I took the y-axis and I pulled really a lot this time because it's way thinner. So this is another vertical stretch, and it's by 5. So I need to look at 1/2. So I'm going to delete that, and I'm going to do 1/2 in here. So I'm going to go ahead and hit graph to see this 1/2. Well, it got really fat or much flatter. So again, I've got the y-axis in my fingers, and in order to get this blue part to lay down, what I did was I took the y-axis and I smashed it. I pushed it together, which is what we call a vertical compression. The top and the bottom, and I smashed them together, which forces the V to come out, and it's a compression by 1/2. So we're going to do 3/4. Notice this one is also thinner, but not as, wider, but not as much. So I didn't smash it as much, but I did still push it together. So I've still got, you can shorthand this to vertical comp by 3/4. Okay, so this column, all the numbers come from the front, which is A. So we're talking about A here. It's a vertical compression or a stretch. And what's important is it's going to stretch at 2 and 5. So that's when A is bigger than 1. 2 and 5 are bigger than 1. So I'm going to compress when I'm less than 1. 1/2 is 0.5 and 3/4 is 0.75, so those are both less than 1. A is like M from linear, which is your slope. So we had steepness, it was steeper and less steep. We just changed up the words here. So we've got one more column. And I'm going to put that as a negative, not a minus sign. So that's a negative absolute value of x. And there's my parent. So we took the V and we brought it down. That is called a reflection. So it's going to reflect, and notice that it's a vertical reflection. It's coming down over the x-axis. So now I'm going to plug in negative, and then I'm going to go 2. So I need the negative 2 absolute value of x. So I can see that it's still reflected, but notice that it's much thinner. So I took the y-axis and I stretched it. I stretched it out in order to make it thinner. So this is still a reflect over x, but it's a vertical stretch over the x. I'm sorry, vertical stretch by 2. I said the wrong thing. Vertical stretch by 2. It got thinner. So I grabbed the axis and I pulled it apart. Negative, and then we're going to do alpha y equals. We're going to put a fraction in here. We're going to put 1/2. So go ahead and hit graph, and I can see that it did still reflect, but it's much wider, which means I took the y-axis and I smashed it. I compressed it. So we are still reflecting over the x, and we're doing a vertical compression by 1/2. So what you need to understand is the negative is its own piece of information. The 2 is what tells me if I'm stretching or compressing. Not negative 2, just the 2. 1/2 tells me I'm compressing. The negative is the reflect. They're separate pieces. I don't say, oh, this is a negative 2, I'm less than 1, so I compress. That's not how it works. So with the negative, I'm going to reflect over the x. 3/4 is the only thing I look at. It's less than 1, so I'm going to have a vertical compression. So we're talking about negative a here, and negative a is a reflection, which is just like your negative m for linears, which you're talking about slope again. So let's work on these examples. The first one, and I'm going to use these pieces right here to help me. The first one in front is A, and that's up here. So in front is A. There's nothing in the middle, so I don't have a C, and at the back is D. So I'm going to go here and I'm going to find A, but A is just a negative, so I'm in the wrong section. I'm going to go here, which is a reflection. D is right here. Notice I was moving up and down, so I'm going to go down 3. And those are the transformations for this function. For the second one, B, the 3 in front is A. At the front is A. In the middle with X is C. And at the back is D. So we're going to state what happens now. A at the front, here's A. Less than 1? Nope. It's 3. It's greater than 1, so we've got a vertical stretch by 3. The next, we've got plus 1, which is C. Here's C. It's the horizontal shift, but see how I said it's the opposite? I have a plus 1, which means I'm going to go to the left one. And then I have D. D is over here. Vertical shift, it doesn't say anything about opposite. Notice when it was minus, it went down. So we're going to go down 1 for D. Alright, last one. In the front is A, inside is C, and at the back is D. It goes in alphabetical order. The letter you're missing is B. That's next semester. I have a negative at the very beginning. There's the negative. It says reflect. And we're going over the x-axis. 2/3 doesn't have anything to do with the negative for transformation. So 2/3 is still A. That's less than 1. So we have a vertical compression by 2/3. Plus 2, that's the C, so I'm up here. Plus moves me to the left, so I'm going to go left 2. And D is over here, and I'm going to go up 1. Okay, so we have 2 graphs to practice. The first graph, you need to identify right here what the vertex is. I moved right 1. And I came down 1, 2, 3, so -3. 1, -3 is my vertex. 1, -3 is my vertex. Notice the parent started at 0, 0 for a vertex. So I moved it right 1, so I can go ahead and write this down. I moved right 1, and I came down 3. Now, what caused me to move right or left was this letter right here. See, left and right horizontal is C. That means when I write my function, inside with X is a 1 because I moved right 1. But look up here, if I was going to move to the right 1, I should have had a negative. So I'm going to have to put X minus 1. Then I came down 3, and what moves me up or down is this guy right here. So he goes D at the back. C, D. Left and right is C, up and down is D. So the last thing I need to do is come up with A, which is the slope out front. So notice I start here, I go up 1, 2, to the right 1. If you draw a right triangle like we used to do, up 2, right 1. So my slope is 2. I'm not opening down with this V, so it is not negative. It did not reflect. And the 2 tells me that that is a vertical stretch greater than 1 by 2. So there's my transformations. There's the equation from the graph. Okay, last example here. My vertex is at 0, 0. I didn't move left and I didn't move right. So that's going to be X plus 0 because I didn't move right or left. Horizontal. That's C in there. I didn't go up or down vertical, so that's going to be plus 0. So I've got to count the slope. It opens down, which is a reflection, so I know I need a negative. And notice I go down 1, right 1, down 1, right 1, so I just need a negative. So the real way we would write this, since there's no C and there's no D, is negative absolute value of X. So my only transformation is that it reflects. Attached is the assignment to work on.